Yeah, you're welcome to Muto Online, your online school. Uh, Before you today is teacher Mugulumiza Noah, uh, a physics and math educator. So this time we are going to learn about mappings and relations as you see it on the board. This is a senior 2 topic under the new competency-based curriculum. So I'm just basically here to simplify this topic. Many times learners tend to take math hard, yet it is the simplest of all, simply because of maybe the negativity and the negative attitude towards the subject. So compose yourself for this lesson. By the end of it, you must have learned something. Subscribe and share. So mappings to begin with, and relations. Relation is from relationship, the pairing or a connection between two objects. We can have set A and set B. Then there might be some connections between set A and set B. Now, the connection between these two sets A and B is what we call as a relation. Now, but in mathematics, we represent these relations using arrow diagrams. Now, when we use the arrow diagram and we represent set A being connected to set B, that is called a mapping. And under this, we have quite two important terms to note in a mapping and relations. We have what we call the domain, and then we have what we call the range. Now, the domain, it is the input values or a representation of all the input values. Then the range, it is the output values. So basically, it is the domain that gives us the range. So much as these two sets have a connection, as if we can have an example here. If I have set A being related to set B as follows, if I have two sets, then I have in set A, this is my set A, and then this is my set B. Now my set A will become the domain, which will give me the range on the other side of set B. So if I have values 1, 2, 3, maybe 4, and then this side I can have 6, I can have 8, I can have 9, I can have 10. Now, when I say 1 gives me a 6, a 2 gives me 8, a 3 gives me 9, and a 4 gives me a 10. This is a perfect example of what we call a mapping and relations. They are represented on an arrow diagram like that. One side is the domain and then the other side is the range. The arrows are always pointing the side of the range. So they originate from the domain part and then they terminate on the range part, as you can see there. So 1, 2, 3, and 4 are my domain values or the input values, and now they are giving me the output values as 6, 8, 9, and 10. In this case, you can be required to write the domain values. What are the domain values? So simply here, when you look at this, the domain values will now be 1, 2, 3, and 4. You create a set for them, and then the range values or the output values will be 6, 8, 9, and 10. Now, we have types of mappings, and the type of mappings depends on how this mapping is actually resembling. We can have different pairing of numbers or pairing of objects. If one goes with only if an element in the domain part has only and only one member of the range, then just like you were seeing here, 1 goes with a 6, 2 goes with 8, 3 goes with 9, and 4 goes with 10. That type of mapping is called one-to-one because each member of the domain is going or is tallying, is connected by only and only one member in the range. So one goes with one. And so since there is no sharing of elements in both the domain and the range, so this is a one-to-one type of mapping. Other types of mappings, we can have many to one. We had one to one, one to one. Then we can have one to many, and then we can have many to many. Now, for one to one, we will say that every member in the domain part goes with only one member in the range. How about many to one? Many to one simply means that more than one member in the domain will go with only and only one member in the range part. Now, it's like having a daughter. Now, actually, we can have, if I'm the parent, I can have, say, maybe 4 daughters. I have daughter A, I have daughter B, have daughter C, and daughter D. But all these daughters are mine. So I'm their parent. So that means they all subscribe to the dad, only one dad. So you see that they are all subscribing to this. They are all my daughters. So this kind of mapping is many to one because you are seeing that they are originating from different points, but they are all terminating at only one point. So such mappings are called many to one. Then for one to many, the reverse is true for this. One to many, that is when an element in the domain has more than one element in the range part. Then many to many, that is a type of mapping where more than one element in the domain still maps different elements in the range. Now, these mappings here, they can be written in a function notation. When I talk of function notation,